If we open up Zeus No Fill and go to World and look at functions, we see the function we wrote last time is philosopher. Well, you would see that from last time's homework. The one I've got here is a newer one from class. Oh, no, I don't, because I didn't save it. Okay, so this is the same condition yours should be in. Is you've got this is philosopher function that says if either possible philosopher equal Plato or possible philosopher equal Socrates, etc., etc., return true, else return false. We want to make this into something a little easier to deal with. It doesn't have this great big long if statement that is fairly confusing and can be difficult to put together and get it to work right. So let's take this piece of code and just get rid of it. So we can hit delete and drag up a new if then else statement. If true, and then drag possible philosopher down into the true and say if possible philosopher equals Plato, the entire Plato, then return true. So click, drag a return tile up there, return true. Else, we can't return false here because it might be Socrates. So we can do one of two things. We could either put another if statement here under the else, or we can put one after the if block. And for now, we'll put one after the if block, and then we'll nest them later. So if true, possible philosopher equals Socrates, the entire Socrates, return true. Then another if then else statement. If true, yeah, just if true. And then drag possible philosopher down there, drop it on the true tile, equals Euripides, the entire Euripides, return true. Else do nothing. Then finally one more. If true, drag possible philosopher down into the true. And if he's equal to Homer, the entire Homer, return true. And of course, if you wanted to protect one of the philosophers, you could put false here. Now, very important step after putting all those return trues. If it's a philosopher, we need a return false down here before this return true. We want to make sure that return true never executes. And in normal programming, you wouldn't put that there, but Alice puts it there and won't let you remove it. So we just need to make sure that we always control the execution and it doesn't go to their default. Okay, now if we play it, we should find that if we try to zap something other than a philosopher, nothing happens. But if I click on a philosopher, he gets zapped. And that all works and works well. If we don't like this particular style, and as I explained in class, sometimes this is, in this case it's okay, but there are times when you really don't want all these if statements following each other because it can be extremely inefficient. In this case, it's fine, but we could nest them. And so everywhere there's an else, we can drag the lower if into it. And it also reduces our lines of code a bit, makes our code a little smaller. And it's a matter of taste at that point. We leave our return false there, and the return true, of course, down at the bottom we cannot do anything about. And then hit play again. And once again, if I click on anything other than a philosopher, nothing happens. If I click a philosopher, he gets zapped. Okay, that all works, and now we're done with that program. Okay, open the Shark Goldfish program and play that. That is included in the email as an attachment. And you can see the shark eating the goldfish, and you could replay that a couple times and notice that it always plays out a little differently. Now, what we're going to do next is take a look at all the methods and what they call. For example, everything in our events window, we see when the world starts, do my first method. So take a look at my first method, which is here. What does that call? It calls chase. Now take a look at chase. And by the way, that's world.chase, so you want to select world and then chase under world methods. What does world.chase call? It calls shark.swim, goldfish.flee, and shark.eat. So we need to open shark, and there's a reason I'm telling you to do this, shark, and then methods, and then look at swim, look at eat, and see if they call anything. And when I say they call anything, I mean anything other than the built-in Alice functions or methods. And then take a look at goldfish, and you can see there's random motion and flee. The reason I want you to go through those methods is I want you to draw a flowchart. That's something you need to get used to doing so that you can edit programs, so that you can understand them. You need to be able to see that high-level view. And in the flowchart, put the goldfish random flee, the goldfish flee, the shark.eat, shark.swim, world.chase, anything like that that does not typically come with the Alice objects. And also put my first method because that's the first one that's called. So stop the video for a few minutes and draw that out so that you have a better understanding of how this program runs. Okay, now that you've got your flowchart drawn, you should realize that my first method is unnecessary. So if we go over to world and we see my first method and edit it, all it does is call chase. And so it's really kind of something that just inserts confusion into everything. You don't need it. So let's take my first method and drag it to the garbage can. It says it cannot be dragged to the garbage can. It cannot be deleted because other parts of the world contain references to it. And it tells me where that is. Okay, it says that the behavior is a line of code whose trigger response is set to my first method. And you can see up here in the events window, there's a big red rectangle around world.myfirstmethod. So X out this can't delete window and take this event and drag it to the garbage can. Now that that event is gone, now I can drag my first method to the garbage can. My first method is now gone. Let's play the program. Notice what happens. First thing it does is it tells me that world.chase isn't called by anything. Alright, that's fine for the moment, so click OK. Notice now when I hit play, nothing happens. Why? Because when we deleted my first method from the events window, we did not replace it with anything that tells Alice what to do when the world starts. So it just goes to the initial screen and stops. So let's create a new event. When the world starts, call chase. When the world starts, do world.chase. Now let's see what happens when we play. Now our world is running, and it's running normally, and the shark is eating the goldfish. Okay. We have a little cleaner program now without an extra method that did absolutely nothing. As we found out in class, when we run this program over and over again, every time we run it, it runs a little differently. Let's take a look here in world.chase at this while loop. And the while loop is set so that while the goldfish is more than half a meter in front of the shark, it executes the loop. Once that is no longer true, in other words, the goldfish is half a meter or less in front of the shark eats the goldfish. What if we want to know how many times this loop runs? We could try and count how many times the shark swims, but that could be cumbersome, especially if it's 150 or something like that. So even if it's 4, we might lose count. So what we can do is we can create a new variable, and we'll call it loop counter. And it is a number. And we want it to initialize as 0. So start with 0 here. And hit OK. And then what I want to do is every time this while loop executes, I want to increment loop counter. And so I can drag loop counter down here into the do in order block and click the increment loop counter by 1. Now if I wanted to do something different, I could. That's just one of the neat options Alice gives me, and that's what I need for this. Now run the world. Okay, so loop counter is incrementing, but it doesn't really do me any good because I can't see it. So what I'm going to do now is I'm going to right click on loop counter and say watch this variable. Now when I hit play, I get a little watch window over here, and loop counter, by the way, doesn't have to be the only thing that's being watched. I can put, there's a long room for a long list here. I could put all kinds of things in there and watch them if I wanted to. If I wanted to watch, say, 10 or 15 different variables, I could watch a lot of them. And that can be extremely useful, especially when you have a large, complicated program and you're trying to figure out why it isn't working the way you think it should. Okay, let's take a look at goldfish.flee. So click Goldfish Methods, Flee, Edit, in order to try to understand why the program runs a little differently every time it runs. Normally, if you write a program, unless the user is doing something to change the behavior of the program, it should run exactly the same way every time it runs. It should be very predictable. Well, we deliberately wanted this one to be unpredictable, and so we have in Flee, we have a method being called random motion. And random motion is being passed values that range from negative 0.2 to positive 0.2. So let's take a look at random motion. And random motion is telling the goldfish to either move up some random number, which could be a negative random number, which means move down, or to move left a random number, and that could be right if the random number is negative. And we always want the goldfish moving forward. So the goldfish moves forward a random number, but the minimum for the random number is 0 so that it never moves backward. And you are free, of course, to play with those numbers any way you want if you want to make it more difficult for the shark to catch the goldfish, just like we did in class. And that is it for today's homework.